Hello and welcome to Func Prog Sweden. My name is Magnus Sedlacek and I'm the host and organizer of Func Prog Sweden. First, I would like to welcome back all our recurring participants. Welcome back to Func Prog Sweden. And then welcome all new participants to Func Prog Sweden. Func Prog Sweden is the meetup where we explore functional programming languages like Haskell, Rust, Agda, Scala, Erlang, and more. We also explore functional programming concepts and paradigms. And finally, we also explore functional aspects of imperative languages like Java, C++, and Python. Then let's head over to today's agenda. First, there will be a short introduction by me, Magnus. And then we'll head over to the first presentation, Building a Vite plugin for F# by Florian. Florian will explore the synergies between F#, Fable, and Vite to understand the craft bridging diverse ecosystems, the diverse ecosystem to enhance the developer experience. Florian is currently a freelance software craftsman. Then the second presentation will be Introduction to Rock Programming Language by Richard Feldman. Rock is a functional programming language that has fast, friendly, and functional as its slogan. Richard has also promised some live coding during the presentation, so we look forward to that. Then, after the live stream, we'll head over to Discord, and you can ask the presenters questions that are a little bit more elaborate than you can ask in the chat. But first, thank you very much, Beat, for sponsoring the live stream. If you want to know more about Beat, head over to their webpage, otherbeat.com, or check them out in social media. Then the coming schedule for the coming months. 11th of June, we're back with another Func Prog Sweden. Then we'll set dates for August and September and come back with that. And remember, if you want to present or have someone you think you should present, please just contact me, Magnus, either on the Discord server or on MeetUp or on social media if you're interested and have some material that you want to come and present at the Func Prog Sweden meetup. Then, of course, if you want to support the Func Prog Sweden community, you head over to MeetUp and join our meetup group, and make sure to head over to YouTube, where you're looking right now, and make sure to subscribe also to the channel. And of course, you can always join the Discord server, Func Prog Sweden Discord server. You'll find the invite on both the meetup and on YouTube, where you can meet other people interested in functional programming. If you have questions during the presentations, please just write them in the chat and I will bring them up to the presenters. Also, if you want to get a t-shirt like this, head over to the shop and buy one. We don't make any money on the t-shirts. These are just for fun and promotional of functional programming. With that, let's get started. First presenter, warm welcome, Florian.
Hey.
Hey. Yeah, good. Well, welcome to Func Prog Sweden, Florian.
Thank you. All right. Can I dive in?
We see your presentation.
Yes. Wonderful. Thank you. All right. Not gonna lie, a little nervous, but here goes. Welcome, everyone. My name is Florian, and today I want to talk about a Vite plugin for F#. So this talk is going to be about F#, JavaScript, front-end tooling. Before we dive in, just a little bit about me. I am a Belgian freelancer. I do a lot of my work in open source development these days. I'm part of an organization called G Research, their open source software team. And because of that, for the last 2 years, I've been able to work on a lot of F# open source tooling, going from the compiler to various other development toolings. Think like JetBrains Writer. Their F# tooling is actually open source as well. contributed a little bit to the Ionite family of projects. And so I'm definitely very interested and very versed in the F# ecosystem. And I'm also a little bit of Fable enthusiast, which brings us to the topic of today. I'm going to cover a lot of things which are very niche, and it's going to be a bit of a deep dive into a lot of stuff. So let's go down the rabbit hole, but start out easy with just a little bit of a glossary and sort of build our way up. First off, I mean, I kind of assume we all know what F# is, but in case somebody's really outside of the .NET space, F# is like the younger sibling of C#. It is functional programming for the .NET runtime. Think of it as the OCaml or Haskell for .NET. But yeah, I mean, F#'s been around for a while, so I don't think there's much need for introduction. I'll be using F# today during some demos, but not really touching a lot on syntax. It's definitely just an ML language in that regard. Then next we have Fable. Fable is a compiler or transpiler that can transform F# source code to other languages. The most popular and starting point was F# to JavaScript. But these days you can also transpile to Python, to PHP, to Rust, and some other languages. But when I talk about Fable today, I really mean like F# to JavaScript, because that sort of ties into the whole Vite story. Then we're going to talk about Vite. Vite is, en français, c'est Vite. So that's like the name of the development server. Vite has a similar sphere to what you may have known from Webpack. They are fundamentally different when it comes to their implementation, but they can both launch like a dev server where you can edit front-end assets like JavaScript, HTML, CSS, do little changes, and then have like an instant browser refresh to reflect what you currently are doing. Vite has a lot of good out-of-the-box standards. So it ships with a bunch of default plugins, and your initial Vite experience is actually quite good in terms of what you're after. The critique of like something like Webpack was that there's a lot of configuration, and you really need to understand the internals about how bundling works. Vite is like a very much nicer way of getting going. And the moment Vite can't, help you with the out-of-the-box experience, you can use plugins to cover all your needs. Okay, so now that I've explained a couple of words, I want to tell you, well, why did I create a plugin in the first place? As I mentioned, Fable transforms F# to JavaScript. So at a certain point, an F# file on disk became a JavaScript file on disk, and then Vite can just pick that up and then kind of rolls with it. So in a certain sense, Vite doesn't really need to know that your your JavaScript was once an F# file. So the thing is that can act as a sort of a pipeline, and that's really nice, but at the same time, it's a little clunky. And I kind of want to demonstrate how you would do it today, how you would create a Fable application and then hook it into Vite, and talk a little bit about how that experience looks like. You will need a JavaScript runtime, because that's simply what we'll need for Vite. I'm going to use Bun because I'm a Bun guy, but you totally do not need to use Bun. Most people still use Node or Deno, but just fair warning, I'm going to use Bun today, and I like saying the word Bun. First up, we're going to do bun create Vite, the scaffold or Vite application. I'm going to call it my Vite project. There we go. And I'm going to do a little demonstration with React to highlight one of the nicer features. I'm just going to choose JavaScript, and eventually we'll go and then use Fable for that. So first up, let's go my Vite project, open this in VS Code. I need to install my dependencies. This is all very typical front-end stuff. And once I did that, I can do bun run dev, which starts the Vite dev server. If I open that, the browser opens. And this is really a very nice introduction if you've never ever seen this, but this is a React application. So we didn't really cover React, but it's not super important to understand much of React. But in any case, I have a little application. It has a counter. I have a component that's linked to that. And what I can do now is I can edit the layout of this component, save the file, and then it instantly refreshes the browser without doing a full page reload. And you can see that my counter is still intact. So that is really the power and the magic of something called Vite, which is this dev tooling. Now, it's not the first of its kind, but Vite really pushed for this entire experience, this hot module reload as we see it here, to be part of like an official browser standard. So that's sort of one of the key differences that Vite brought to the table. If I now want to do basically the same thing, but instead of going with a JSX or JavaScript file and use a Fable file, I can start with creating a new .NET application. And I'm not going to lie, I actually need to do a couple of CLI commands to really get going. So I kind of prepared a little script, but I'll go over what I'm actually doing in a bit. So PowerShell, new Fable. It really is just a succession of .NET CLI commands, but we need an F# project. We need the Fable CLI tool. We needed a package for the React binding. So we just needed a couple of things. And when I do a .NET tool list, it shows all the .NET tools I've installed. And one of them is Fable, which we can use to compile the JavaScript. I'm going to use the word compile, where I sometimes actually mean transpile. So depending on how nitpicky you are, I mean, it's the process of putting the F# to Fable. So that's those can be used interchangeably. Cool. So quickly, I scaffolded an FS project because in F# the file order matters. If I have like a bunch of files in this, so imagine I don't have like an extra file, but imagine I had. If I have something in a.fs, then A cannot use any functions that are defined in the library because the order in F# matters. You can only use certain functions and then records after they have been defined, and that's why you, for one reason, need this fs_proj file instead of just going with like something file-based and importing from a certain file. Now we can use Fable, the .NET tool I just installed, pass it this app_fs_proj. It will look into that and target all the files over here. This library file is empty. I'm just going to scaffold the same code as you would have for the React component. So over here we have like a fragment. It has a div and anchor tag. I just tried and mimic the same thing. There's a fragment, there's a div, there's an anchor tag, and this F# DSL just takes in two lists. So each of these things, which has like an HTML element kind of name, just looks at, takes two lists, the first one for the properties and then the children. So this is, hits very close to what React is doing. And I am going to say that I want the extension of the compiled file to be .jsx. And that's because Vite is, has a way of dealing with JSX files. That's how it really wants the React thing to play out. Now I ran Fable. I have now library JSX, which has a fragment and also JSX syntax. So these things look very similar. When I do bun run dev, I'm starting the web server again. I am now, instead of going to import app from the app.jsx file, let's go one level up and then use the library JSX over here. And then you have this hey from Fable. And if I click on this and update this a little bit, well, it doesn't work because the Fable command was like a one-time thing. So I'll need to split and go to like another terminal, do the .NET Fable app JSX thing again and pass in a watch flag so it keeps watching my files. And once it's done that, we'll have more or less the same experience that I had in my JSX components. So it's starting, it says, hey, from Fable. I change the file and it updates automatically. So that's good, but I'm already a little bit annoyed by the two terminals. There's actually something we can do about that. If I were to stop the Vite dev server, sorry, over here, close that, I can actually run the Fable command again and then pass in a run argument and then go with bun run dev. So for those who have absolutely no idea what the bun run dev does, it just runs the script defined in the package JSON, which then again runs Vite over here. And if I do that, then both are sort of going to work together in the same terminal. So Fable first, and after compilation, it started whatever I passed it over here, and now we have the same effect in one terminal, so to speak. All right. So that is how they would recommend you to do it today. And going back to the slides, I'll have some reservations on it. I'm going to do a little bit of nitpicking. First one is that I think Fable's kind of weird. I don't really know any other tools in this whole Vite ecosystem where I need to start the other tool first and then start Vite. So that just doesn't feel really good to me. When you look at something like Elm, you wouldn't do it that way. There would be an Elm plugin, which sort of foreshadows what I was after. And the other thing is that I'm a consultant, and if I go into a company and they already are using Vite and TypeScript, and I need to explain this whole thing, yeah, but we should use Fable because it's F# and functional and way more cooler, then having to explain this way of doing it will just feel like a step back. So I don't quite, it doesn't quite feel well in terms of what is the rest of the ecosystem doing. And Vite is a lot bigger than our little Fable universe, so it should be the leading case in this. Another thing that really bothers me is that I first need to write the JavaScript to the disk, and then Vite reads it again from the disk. So that feels a little bit unnecessary. If that could be done in memory, I feel that would be more efficient. It's not the memory or the performance thing that really bothers me, but it's just that it could go wrong. Like, what if Fable is still writing to a file, Vite's already reading it, stuff like that. So that's just something I would kind of want to avoid. And then lastly, actually I forgot to mention this, but if Vite is configured, I want it not to watch my F# file. So there's a little bit of a configuration that you typically need to do. The docs recommend that Vite does not watch your F# files because Fable will watch them itself, and then you end up with like two watchers, which I just don't really like that separation of concern kind of thing. So clearly, these are all definitely nitpicks. Doing this experience, as I just showed you, is still very much enjoyable, and using Fable really is a bliss. So if you've never ever played with it, I definitely recommend it. However, I feel like it could be slightly better, which brings us to the topic of the day, the Vite plugin. And without further ado, I'm just going to demonstrate the damn plugin. So going back to VS Code, I can first remove this little bit because now I do want Vite to watch my files. I'll need to install a couple of dependencies. The plugin can also be installed from npm, and I'm also going to install Vite plugin inspect. I'll show that in a little bit later in a demo why that's interesting. And for the Vite plugin Fable, I also add the --trust parameter when installing. What that actually will do is run the post install script of the Vite plugin Fable. And that's actually very important because this will compile a .NET binary, which the plugin will later use in its run. The --trust thing is a bun thing, and what it ends up doing is that it puts your installed dependency into your trusted dependencies, which again runs the post install of the installed package and thus gives us the binary. I am going to configure these things so I can import inspect from Vite plugin inspect. I can import Fable from Vite plugin Fable, and I'm going to hook these in. So I want Fable first, then do React, and then do the inspect thing. For the Fable for today, we are using JSX, so my JavaScript code still contains JSX, and Fable the plugin needs to know about that to further transpile that. Anyway, if I now remove the library JSX, do a run def, you can see that we have a lot more logging going on. The Fable plugin, it currently makes a lot of noise, and right now we get an error because I just removed that file. So if we change that, what we can now do is instead of importing the compiled file on disk, we can just point it to the F# file, and then Vite picks that up, transforms that via Fable because of the plugin, and we actually have the same result. So when I do the counter, I go over here, I were to update or add like some new content. I say, hey, and then, oh, nice, it refreshed, but my counter's gone, so kind of almost makes me look bad, but almost. Before diving in, let's take a look at the inspect endpoint. So because I added the other plugin, I can go to like my inspect over here, and that shows you what happens in every file that was served to the browser. So in this case, all these files went through the Vite pipeline. I go and see for library.fs, the first thing that happened here was it was loaded from disk. That's just by the core plugin of Vite. Then my Fable Vite plugin Vite thing kicked in, took all this source code in F# and transformed it via Fable to JavaScript. You can also see that the JSX is already compiled. That was the little extra flag I needed to set in my configuration of the plugin. And then this import analysis just, well, allows us to see what we're seeing right now. However, there's one thing missing, and this is just your React component. And to have the wonderful fast refresh magic going, it needs to be wrapped again. And luckily, that's just a bit of a configuration. So in that React plugin, I can say include and pass in a regular expression. So I want to say everything that ends on JSX or FS over here. There we go. So counter hey and delete it. Seed count is still 4. So yes, that worked. And then the inspect will add one other transformation, and that's because of that React plugin. It will actually take all of this and wrap it in what we call the fast refresh hot module. So this import meta hot, that's the well, the web standard I talked about that Vite's trying to embrace to make this whole experience work, and fast refresh runtime. That's really like the React implementation detail to get all this magic up and running. So that was definitely, let's try go back to the slides. That was my demo, and I feel like this is a slightly nicer experience. But the next thing would be, how does this even work? Because, you know, as I mentioned, .NET, Fable uses .NET, so it uses like the F# compiler and all that, and Vite plugins are just JavaScript, so there must be some dark arts involved in to get this up and running. And that is totally the case. The way it works is that during that post-install event of our package, a .NET binary was compiled. I could have just shipped the binaries, but I'm actually shipping the source code. And it compiles a little F# project, which is what I call the daemon, or the sort of language, well, it's not language server, but sort of server.NET endpoint. And then the plugin from JavaScript communicates to that via JSON RPC. It spins up the process, and that process will have receiving messages via the standard input and then giving responses via the standard output. And that's how I sort of bridge the JavaScript runtime and the .NET runtime. When a Vite plugin is actually a set of callbacks, so when it starts, you can sort of choose in which lifecycle hooks, as it were, are you interested. And that is basically when a certain callback hits, and we need to talk to the server, we send our JSON payload, and the server responds, and then we sort of return and resolve a promise, which then leads us to continuing the Vite pipeline. The plugin system itself is based on a set of callbacks from Rollup. So a Vite plugin is in 90% of the cases also a compatible Rollup plugin, depending on if you have the common set of hooks implemented. In our case, the story starts with build start. That's really like something that runs once at the start. Each plugin gets a chance to hook into what the build start is. That happens after the Vite configuration was sort of resolved. And in our case, we need to detect, okay, where's the F# project? Because that's very important. That contains all the files in the project, and it also has a set of references, and we need like a lot of dotnet information to eventually get the compiler arguments. Once we have the F# compiler arguments, we can type check the entire project, give that to Fable, and then Fable will have that typed tree of F# and transform that to JavaScript. We prematurely transpile everything up front and then just send like a dictionary or a map back from the .NET process to the plugin, and like, hey, this is like every F# file path is then translated to its corresponding JavaScript. When the browser is requesting a file from the Vite dev server, it will hit the transform hook. In that transform hook, we did import app from library. It will then detect that library .fs URL. We do a dictionary lookup, return the JavaScript, and that's how it gets to the browser. When we update our F# file, because Vite is going to know that this was now part of our loaded assets, the inspect plugin sort of lists it. And when you change one of these files, the handle hot update hook kicks in. And then we have a chance to talk again to the server, let it know that, hey, this file changed, and maybe one or more files are going to change. Because of that, it kind of has a bit of a ripple effect at times. And then eventually the server replies, we update the dictionary, and then the transform hook will be called again, and everything updates. One last hook is then the watch change, because there are also certain files you want to know if they changed, then we need to invalidate the project. Because when, for example, the F# project file changes, it's pretty much a guarantee that all the files we no longer can rely on the cache, and we need to just reload everything. But that happens more often than you think. When you add a NuGet package, which is like the .NET dependency, when you add a new file, you really need to be sure, and that's why we're watching a couple of files, so that we constantly keep the browser up to date. This actually came with a fair set of challenges, and I definitely want to highlight a couple of things because they're a little less known, and it's kind of interesting to break them down. The first one was that we saw Fable is a CLI tool, and I wanted to do things a little bit different with the CLI tool. And I just had to carve out a little bit of the bits and pieces that I'm actually after. What I want from Fable is more or less just an API function that says, hey, for this JavaScript, for this F# and its project and all its settings, I actually want you to return the JavaScript as a string or like a buffer. But there was nothing really out there that does that. It happens inside of the command line tool, but if you can't just pass it and give it the input arguments that I already had. You can start it, and then it will figure out everything on itself. But then, yeah, it always writes to disk. So there's just a lot of things happening inside the CLI tool, which I don't really want. And I can't really just run at one time and get the result. So TLDR is that I just had to go into the code base and try and extract the things that are useful into a separate project. So we could have another library on NuGet. And one of the more challenging things is it wasn't just moving some files and code. It was, it was quite a refactor. And it's one of those things where I am not a Fable maintainer. I happen to know the Fable maintainers, so we talked about it, but it was definitely a big ask. And what I kind of want to highlight is that I feel the only way I got away with this was just by explaining my ideas carefully through some online calls with the maintainers, really, have them believe in the story and, get their blessing to really do this. So I definitely want to thank Maxime in particular. But when you want to do these kind of undertakings in open source, it really helps to sort of call face to face or, well, remotely. The next challenging thing was the JSON RPC. It sounded like a good idea, and it's wonderful when it works, but when it doesn't, it really sucks. So one of the things that you really need to respect is that you just cannot log to the standard output. Fable was constantly logging to the standard output, and I believe that in the part I carved out, it wasn't there yet until it eventually appeared that it was. And that was quite the needle in the hay, because all you get is like, hey, the plugin cannot deserialize the response from the JSON RPC endpoint that it's talking to, and that's all you get. So it took me a while until the penny dropped that, oh, I'm probably messing up my own JSON payload by something that's writing to the standard output. And then I proposed to have, hey, can we not have a logger interface to deal with this? So I had to go into the Fable codebase again, extract everything after an iLogger, which again, the maintainers were okay with. The CLI tool, which you saw earlier in the demo, still just uses a implementation that logs to the console, but then inside of my plugin, I write everything, I keep it all in memory, because I just absolutely cannot write the standard output. And lastly, I want this, never to happen again. Like, it's very easy to, for somebody new contributing something to Fable, very unrelated, but doing one simple test log, and then eventually that gets shipped and can just ruin the communication between the .NET process and the plugin. So I wrote something we call an F# analyzer, which does code analysis of the F# file, and it's going to fail the PR to the Fable build when somebody is trying to log to the standard output and not use the logger interface. So that's something I entered to preserve that it still keeps working. Another fun thing was what happens when multiple files changes. I gave you a very, easy demo, so to speak. I change one file and then that reloads the browser. But what if you rename a function and on the definition side it changes and it's also used in a couple of other files? So all of a sudden, you basically get multiple handle hot update callbacks, and they all need to resolve a promise, and they all need to contact to the server. And if one of those endpoints trigger, you kind of already know that at most one file changes, but in practice, depending on your side of the F# project graph, multiple things could change. So you either, you also don't want to do the same work multiple times, and that's why I try to batch these things via reactive extensions to have a little bit of a buffer window, capture all the calls, and then eventually, if depending on what changed, send a different message to the .NET process, because maybe 2 files just changed, or another good scenario was when you format all the files, then it also went kind of crazy. So it's good to batch these things, and potentially you're also like adding a file, which will definitely trigger a handle hot update hook for the new file you added, but also for the project file. So the project file eventually wins, and then you know that, oh, I need to invalidate everything. So that's where batching was a good strategy. A next thing is that Vite is very popular. We all love it. It works wonderful, and I would definitely recommend people doing something front end use a tool like Vite. But when it comes to the plugins, it turns out that really not that many people are writing Vite plugins, and it is just difficult to wrap your head around. There is documentation, but you either have to look into the rollup documentation or you don't get like the satisfying answer, because a lot of the documentation explains to you what they expect in the happy path, but doesn't really touch upon what if I know I cannot process the request, but it definitely is my request to process. How do you properly communicate that? Is it okay to throw? Is there a better way of doing it? So those kind of things are definitely tricky. And there are not really that many people in the Vite community that write plugins, and I just don't really have any friends there. So the hard thing about the Vite plugin is that I felt that I had to, develop this on my own because I'm bridging two foreign worlds that usually don't really interact. So the sad part is that I never really had a sparring partner on a call to talk about the Vite specific things. Lastly, I want to talk about what happens inside the .NET process. It's kind of tricky because I told you I cannot log to the standard outputs, and it's kind of tricky to see what really happens inside. I try to do things as straightforward as possible, but it was often misleading when I developed something on my on Ubuntu, like the WSL site, and then tried it on native Windows, and then I had subtle bugs that appeared where I was like, but this was working on Linux, so what's up with that? And they added a little bit of functionality to debug what's happening inside the .NET process. Call it your homebrew gRPC, sorry, not gRPC, telemetry kind of solution. So if I go back to the demo here and I stop it, let me add one environment variable. If I do a bun run dev now, you'll see that it logs I'm starting on 9014, and that actually gives a log of everything that's happening inside of the dev tool, which is also very important. So I get this project change. That's the first endpoint that the build start hook calls. Then it has this response of all the .NET things it needs to know, because unfortunately that's a bit of the reality. .NET needs a lot of information for the F# compiler to kick in. And then eventually I have these logs like, hey, it's type checking, it succeeded, it's going to send this back to the client. When I were to update a file over here, I can see that more logs are being added, so that's kind of nice. And one interesting thing, you can't really see it, but this is a log that's actually coming from Fable itself, so I can reuse the entire iLogger thing. And if I ever need more information about what's happening on the Fable side, I can just opt into that when I contribute some more logs. So that's definitely has been very helpful in terms of figuring out what's really happening. And now I do want to answer a little bit of a question. Should you use this? I feel like it's nice tech, but I definitely value honesty and I want to be upfront about a couple of things. Is this whole thing sustainable? Well, it's something you can't really, ask funding for. And yeah, I mean, everything that it touches is free to use. Fable's free, .NET's free, Vite's free. So it feels weird that this becomes like a product. And I also am not using this really in an enterprise context. So I did a lot of F# work, but my recent clients are not using any Fable. So this was really just a pet project, and I can't say like, hey, I use this every day, I know it works. That's not kind of it. I use it for my project, which I tamper with in the weekend, and that's sort of the little bit of a reality there. I also went to FOSDEM this year. FOSDEM is one of the largest open source conferences in Brussels. And I went to see a talk, Take Your Open Source Project from Surviving to Thriving, where the speakers kind of mentioned that you need to have a plan when you're making something for open source, when you're putting it out there and you're sort of like inspiring people like, hey, this is cool tech, maybe use it. There needs to be a little bit more to it. Because we see this all of the time. You typically create these things out of passion. You definitely find the energy to prototype that. You're happy. I'm kind of proud of what I did here. So I published this on NPM, like, hey, people can use this. But when I came out of that talk and they were like, yeah, but is this sustainable? Is this really a good idea for businesses to start use? I was like, yeah, shit. I have no plan whatsoever with this. So I have a couple of options, of course. I could maybe hope that this gets adopted by the Fable maintainers and then we move it there. But at the same time, I don't feel good about, putting additional burden on them. They're already, there's not enough manpower to maintain Fable today. So just adding another project of the week doesn't feel right. And purely on a logistic level, if I move it from my local, from my own user GitHub repository to the Fable one, in practice, I just see it dying under a different name. So that doesn't solve anything if there's nobody else ever going to touch it. I could try and build community. I could try and convince existing Fable users to start using this, then try and trick them into maintaining this. And truth be told, that's very difficult. This whole project touches a lot of niche things, which most developers don't really come across quite often. I'm talking about the .NET compiler side, the F# compiler, the Fable compiler, the Vite plugins. It's less done, and it's very hard to find people to really, have meaningful PRs for these kind of projects. It also just sits into a lot of moving dependencies. There will be a new version of Vite. There will be a new version of Fable. There will be a new version of .NET and F#. Will this all keep on working? Maybe, but also definitely maybe not. So yeah, who knows? That's just a little bit of a reality check there, that it just sits in between all these other pieces. So it's hard to say what's going to be the outcome of the code I have right now in, say, a half-year time. And frankly, I have to admit, I'm a little bit out of juice in terms of supporting these kind of things. So yeah, if anybody's interested, this project is really open for adoption. I'm happy to transfer it to anybody that, wants to use this, wants to get the most out of it, and then has, the project's best interests at heart. So please reach out if there's any interest. To answer that question, should you use this? Today, absolutely. It worked fine for me. If your project is not doing is a little bit along the lines of what I had and what I tested, then it will probably work fine for you. If you want to use this for a project that has a longer run, you might not be afraid, need to be afraid to actually fork it and potentially fix something on your own if I don't have the bandwidth to review any PRs or anything. That sounds a little bleak, but it's just a little bit reality. So I don't want to exclude that part and make this sound as a very, oh, definitely use hot new thing kind of story. But that being said, I did write some documentation. So if we quickly glance over this, there's little documentation. How does this work? Technical implications. So it touches a lot of things. How do you configure everything based on what you might have? How does the debugging thing work? So I do very much, I was passionate to really see this through, and I also, because I'm giving this talk, that kind of helps to see it through. And I also gave a amplifying F# session where we went through the code base. I explained the rationale about certain technical things. And yeah, I feel like it definitely isn't a good place to be adopted. There's not, you can't really have the argument like, I don't know the code base. I did some fair attempts to explain how the code works. If you never heard about amplifying F#, I definitely want to wrap up with this. It's a new initiative that tries to improve the F# ecosystem. F# is owned by Microsoft, and the F# team does a fantastic job. However, they are very focused to the compiler and to its tooling in Visual Studio. Anything else you use in F# is typically, from the community. And the community needs a little bit more love. That's why we organized online sessions. We have a lot of recordings where we try and explain people how do you contribute to all these complicated projects, going from the compiler to parsers, lexers, LSP, some more other open source projects that are interesting. And we really just want more people to contribute, because we can definitely use the hands. We also gave an F# Essentials course. This was a partnership with Ian Russell, where we tried to explain F# to newcomers. And during a 12-week course, which was free, we had a weekly stream again with Ian, where we just teach people how F# works. So we definitely just want to keep that energy in the F# community. We recently also have an open collective. The TLDR there is that if we get some money, we can do more and good in the F# community. We can just think about sustaining some of the maintainers of these projects. the Fable maintainers are definitely on that short list. So yeah, definitely check that out. We have a website. You'll find all the good content there. And without further ado, that was my talk. I was Florian. Thank you so much for listening. If there are any questions, I'll be happy to answer those.
Thank you very much, Florian. Thank you. Very nice presentation. Thanks. I wanted to start with, like, before you presented all like the initiatives with F# Amplify, etc. Like, is this the call for more devs and funding for Vite? Then you kind of went through it. But if there people want to reach you, where should they go? Is it like visit your webpage? I think we put the link out on the MeetUp page if people. Is that the place to contact you?
Yeah, and for the Vite plugin specifically, I would suggest the discussions tab on GitHub to sort of poke me there.
Yeah. Cool. People are sharing in the chat saying very nice presentation. We have one question. It's like, will there ever be a way you can get out of like, is there a way that F# can do without React, like Elm, without Vite or without Fable, just pure coding? Or
definitely, but so the short answer is yes. You could possibly do everything in .NET and try and have that same experience. But on a practical level, the JavaScript community is just so much larger, and they build these fantastic tools like Vite. So I don't know. On a practical level, it feels a little bit. You need a lot of hands and a lot of investment to get on the same level as existing things which are out there and which are hype of the day maybe, but they definitely kind of work well. So yeah, it's a trade-off. I see in theory no reason why you couldn't have a nice experience with only the .NET. But yeah, it's could take years for full-time work to get to that place while
yes.
while Vite is just out there. So I don't know.
Yes. Yeah, that was a question. I kind of agree with you. A lot of people are in thanking you for your presentation in the chat. Like, awesome talk, and like I have very positive experience with Fable, which people can recommend. So yeah, thank you again for your presentation. And if people want to ask you more questions, you will join the Discord server later if they want to elaborate more, have more questions, maybe talk to you around joining Vite project, etc. Or other initiatives you had. We'll also post all the links you have to all the places, Florian, so people can find them afterwards also, of course, if they're interested and want to join. Again, thank you very much for your presentation. Thanks. And now we will do our second presentation. Welcome to Func Prog Sweden, Richard.
Hello.
Hello and welcome.
Here.
Yes.
All right. Let me share my screen real quick. Thanks everybody for coming. All right.
Let's rock away. All
right. Sounds good. Do we want to do anything before I kind of get started, or we're just ready to go?
Ready to go. Hit it away. We see your screen.
Okay. Great. So thanks, everybody. I'm Richard Feldman, and we're going to talk about an introduction to the Rock programming language. So I'm kind of going to assume that everybody here doesn't have any familiarity with Rock, so I'm going to kind of explain some basic high-level stuff, and then we're going to do a whole bunch of live coding. I did want to start by noting, though, that for those who are like completely unfamiliar with Rock, this is not going to be one of these introductions to the language where I expect that by the end of it, you're like, okay, cool, I'm ready to go and like write Rock programs. It's more going to be like, I'm going to give you an introduction to what the language feels like, what it feels like to build stuff in the language. And I'm definitely going to explain some concepts along the way, but don't feel like you're getting lost if I'm not explaining every single detail. So we will have some time for questions at the end. But my intention here is explicitly not to try to give you a really deep understanding of the language. We got a whole tutorial for that if you're interested, but rather to give you sort of a feel for like, this is what it's like to build Rock programs. Here's kind of like the way the language sort of feels. So briefly, it is a fast, friendly, functional language. It's under active development. I would say that it's sort of mature enough that if you want to use it for real things, you absolutely can. However, it's also pretty bleeding edge. Like you can expect some sort of alpha level quality of things. There's definitely some compiler bugs. We may or may not run into one of them today. The ecosystem is quite small at this point. It's not battle tested at all. Nobody, as far as I know, is like using it in production for, you know, serious stuff. Like there's kind of little projects here and there. But at the end of the day, if you're interested in sort of, you know, being on the bleeding edge and getting like the early experience of using a language that has a lot of nice characteristics, I absolutely recommend trying it out and trying to build something with it. Okay, so this is a little bit of snippet of rock syntax. Obviously, we're going to see plenty more rock syntax, but very briefly, this is an assignment. So rock is a language where you don't have a concept of mutation. So once you assign this, it cannot be reassigned later. This is list.map. This is a function call. So function calls in rock are done with white space. And then finally, this is what a lambda looks like in rock, like an anonymous function. You have a little backslash, which is, you know, kind of looks like a lambda if you squint a little bit, and then an arrow after the arguments. And then this right here is a string with a little bit of string interpolation. And so we're going to use all that stuff over the course of this live coding. So fast, friendly, and functional, generally speaking, what we mean by that, in terms of fast, it's like we want to have a fast compiler and fast runtime, that like both of those are values. So we're going to see a fast feedback loop as we're doing this live coding. Not going to get into any benchmarks and stuff, but we've got some benchmarks around of, you know, being quite a fast language. We try to generally be faster than Go, but not as fast as really systems level languages that do their own memory management. So we're not trying to compete with like Rust, C, Zig, C++, languages like that, but rather among languages with automatic memory management, we really kind of want to be the fastest game in town. Friendly, so, you know, user-friendly, sort of friendly syntax, friendly error messages, friendly community, all of these things are important to us. And finally, functional. We are at Func Prog, Sweden, and this is a purely functional programming language, as in functions don't have side effects. All effects are managed explicitly, which early on might not feel like that when you look at the syntax of a lot of the I/O we're doing, but I'll explain a little bit later on how actually under the hood, these really are genuinely all pure functions. Okay, so with that very brief introduction to the language, let's dive in and start looking at some code. I'm going to be using the Z editor. This is has been for quite a while my favorite code editor. Actually, I like it so much that I'm joining the company in about a month to work on Z, because I'm just like, this is the way that editors ought to be. It's really fast, it's really lovely, and we're going to see a bunch of it today. So this is sort of hello world. This is a really basic, just like main equals standard out.line, hello world. I'm going to talk about this other stuff up here a little bit later. You can probably kind of guess what the imports do. They import modules. This part is what we're going to talk about a little bit later. This is sort of how you bring in packages. And we're just doing hello world here. So let's just run this at the command line. I'm going to say rock dev demo.rock. And there we go, hello world. Let's, we can modify it a little bit, add some exclamation points, rerun it again. Hello world, very cool. Let's make it a little bit more complicated. So I'm going to change it from just printing out hello world to first printing out enter your first name. Oops, first name. And then we're going to do first name equals stdin.line. And you're seeing we're getting an error right there real quick, and I'm going to explain that in a sec. And then enter your last name. And this is going to be last name. And then finally, your full name is first name. And hey, thanks, Copilot. Cool. So already we can see that we're getting a couple of errors here. And this is because Rock is a fully type checked and fully type inferenced language. So it's giving me an error here because I have not imported the stdin module here, module not imported. So as you'll notice, like early on, I'm actually going to write no type annotations for quite a while. And then later on, I'm going to go through and add type annotations because they're totally optional in Rock. And I want to show you sort of the trade-offs of, if you want, you can start off writing without type annotations, or you can write them from the get-go, and then you can optionally add them later. So let me go ahead and import standard in. Okay, and there's that. And now let's run this. Enter your first name, Richard, enter your last name, Feldman, and there we go. Your full name is cool. Okay, so this is a little bit of I/O here. I'm going to talk about this exclamation point operator a little bit later, but basically you can kind of get the idea of like the things that are doing effects, like printing out to standard out, reading from standard in. They have the exclamation point after them, whereas other functions like that list.map that we saw earlier on the web page, those don't have the exclamation point because they're not doing any effects. Cool. All right. So that's a basic command line. But as a lot of people have told me that one of the things that they're most interested in using Rock for is for web servers. And this is another one of the use cases that Rock is targeting. So let's take a look at that real quick. So I've got one of these open in another tab rather. So this is a really, really basic web server written in Rock. And all it does is whenever we get a request in, we actually ignore it. So if you have any kind of variable name or argument name that starts with an underscore, that means it's going to be ignored. If I take off the underscore, it's going to be like, hey, this is unused, which, fair enough. So underscore is just there to silence that error. And then essentially all we're doing here is every time we get a request in, we're saying task.ok, meaning like I'm just sort of responding with this value. And we're saying status 200, no headers, and the body is just stir.toUTF-8, hello from the server. So I'm going to open up a different terminal tab and do once again, rock dev, but this time I'm going to do server.rock. Okay, so now we're listening on this port. I'm going to open this up in the browser. Hey, hello from the server. Fantastic. All right, so, and of course, if we can change this, we can throw some more exclamation points in there, and then I have to restart the server. In the future, we like to do hot code loading, and we sort of have a design for that, but right now it's just, you do actually have to restart the server every time. But as you can see, it loads up pretty quickly. All right, cool. So let's make this server a little bit more interesting, because right now it just sort of hard-coded always returns that thing. And let's do this by actually looking at the request. So we're going to do a little bit of pattern matching here. So this is actually an example of like Copilot obviously isn't like language aware. This right here kind of might look like it's valid Rock syntax, but it's actually not. Like this is a little bit of like hallucination kind of. So I'm just going to ignore that. That is something you have to watch out for. I mean, with Copilot in general, but also, especially with like a new language. So we actually want to do is request.url, and we're going to just match on slash and have slash continue to do this. And then I'm going to add another branch. We'll refactor out this code duplication in a sec. Let's see. Let's do slash foo, and then foo is going to say foo. And this one's going to continue saying hello from the server. Now, you might notice that we're getting an error for all this. So what is the exact error here? Well, the problem is essentially that, well, first of all, that I deleted a close quote there. Oh, yeah, by the way, we have a Rock format running on. So this is the Z extension incorporates both Rock format, which is a formatter that's actually built into the language. It is zero configuration, much like Go and Rust formatters. So you cannot configure absolutely anything about it, which is a feature because that means that there's absolutely no settings to argue about on your team. And then also it comes with like the language server has like an LSP and stuff like that. So it's got, basic autocomplete and stuff like that. It doesn't have as many things as other like LSP implementations do, but it does a pretty nice job. At any rate, the reason that this is giving us an error is unsafe pattern. This when does not cover all the possibilities. Okay, so what are the possibilities that's missing? Well, we're only currently matching on 2 different strings, but of course there can be infinitely many strings in theory. So let's just have a little default here that gives us back like a 404 error. And this will just say not found. Okay, like I said, we're going to make this a little bit nicer later on, but for now, this is a very, very basic web server that will do a little bit more. So now we've got the root, which still says hello from the server with 1 exclamation point. We've got our /foo route, and that says foo. And then if I do anything else, like some gibberish in here, it just says not found. All right, very nice. So very, very basic web server. We can refactor this out a little bit. So let's see. I'm going to make a little function here called respond, and it's going to take status, and it's going to take, actually, I'm just going to always hard code the headers to be nothing. And then I'm going to take body, which is going to be a string. So let's just refactor this out, and I'm going to do a little bit of multi-cursor stuff here, and this is going to be a respond with status and headers. We're going to delete the headers, right? And then the body, and then we don't need the stir.utf8 because we're going to actually do that inside the thing. And there we go. Okay, so now I'm going to recreate that. So task.ok. This is a little thing called record punning. So it's basically like instead of writing status : status, I can just write status, comma. And then headers, we just said we were going to hard code to nothing. And then body is going to be stir.toUTF8, which is basically because it's sending back raw bytes. We are doing that. Oh yeah, and then I don't want these anymore. Okay, great. One of the things I love about code formatters is, when you've like fixed all your syntax errors because you hit save and everything just sort of snaps into place. Very nice. All right, cool. So let's rerun this and confirm that I didn't break anything. Uh-oh, 2 errors. What did I do wrong? Let me sort of full screen this. This is not planned. I don't actually know what I messed up here. We're gonna find out. Okay, so it looks like we've got body, which is a list of bytes, header, which is a list, status, that looks okay. Maybe header should be, yeah, yes, okay, there's the clue right there. Maybe the word header should be headers. Oops, that was a typo on my bad. Okay, so it shouldn't be header colon, it should be headers plural. There we go. Okay, now let's run it. Okay, nice. All right, and now if I go back here, we should see the same behavior as before, /foo and root. Great. Okay, so we got a nice little server here that's working. But of course, this is not like commonly what we're doing when we're doing a web server. Usually what we're doing is we're sending back some HTML or some JSON. I'm not going to show HTML here because I don't have anything like really fancy to demo. Rock does have some DSLs for generating HTML. But the way that Rock handles JSON, I think, actually is pretty cool here. So I want to make a new path here. I'm just going to repurpose foo and say this is going to be /JSON. And here I'm going to make another helper function, respond JSON. And so this is going to be give me the status, then give me some JSON here as a second argument. And what I'm going to do here is, instead of the body being, I'm going to call stir.toUTF-8 on that body stir. What I'm going to do is I'm going to do encode dot 2 bytes. And encode.2bytes takes 2 arguments. So one is the thing that we want to encode, which is JSON, and the other is the actual format that we want to encode it in. So in this case, JSON. Now it's yelling at me about JSON because I don't have a JSON module imported. Fair enough. I already did add the JSON package here, so I can just import that. Oops. Okay. So encode.2bytes takes the thing that you want to encode, and then it takes the format. So JSON.UTF-8 is basically saying I want to encode it as UTF-8 encoded JSON. I could give it something else. I could give it like CSV. I'd have to import a CSV. Actually, I don't know if anyone's done CSV. Kind of think of it. I think someone's done, maybe they've done CSV. I don't know, XML, whatever. The point is that what I'm about to show you is not specific to JSON. We happen to have the most robust JSON implementation. Plus, that's the one that everybody always asks about. Okay, so I'm going to change this one to be respond JSON, and that will still be status 200. And again, Copilot, this is totally wrong. That's not Rock code at all. But I am going to put something in here. So sure, we can put a message like that. And then let's do a Boolean, like is 1 + 1 2. And that's going to be 1 + 1. Yeah, okay, that was correct. Good job. Let's put this on multiple lines. All right, nice. So basically, this is going to encode this record right here as JSON, and then it's going to return that back from the server. So let's rerun that server. And now when I open up /JSON, cool, we see some JSON here. So this is, you've seen this in plenty of languages. You have something like, JSON.stringify, and you just give it an object literal in like JavaScript, for example, and it sends it back from the server. But it is kind of cool seeing this in a fully type-checked language, not a dynamically typed language at all. Rock is not dynamically typed. It's not gradually typed. There's no type reflection, none of that stuff. This is just like, this JSON encoding right here is responsible for saying, I know how to take a Rock value like this and figure out how to turn it into JSON. And that's exactly what it's doing here. Pretty cool. But what's much cooler than that is seeing that in action on the other side, on the client, when we're decoding JSON. So let's see what that looks like. So let's go back here to this thing. Okay, we don't need standard in. Actually, I want to comment that out because we might want to bring it back later. Let's see. What am I going to do? I'm going to say, all right. So first of all, I need to bring in my JSON package here. So now we've got that, and I'm going to need to import JSON as well. So I'm going to import that. And next we're going to say, okay, so first I'm going to go get some JSON. So I need HTTP. That's important. HTTP. Cool. So I'm going to do http.get, and the URL is going to be, HTTP localhost. Actually, I'll just copy this out of the browser. Great. So we're going to go get that exclamation point, because that is in effect for sure. And then the format is going to be, once again, JSON.UTF-8. And so we're going to get this JSON back, and I'm going to say, got this. Actually, no, I have a better idea. I'm going to destructure this. I'm not going to get the whole thing as a JSON value. I'm going to actually say, you know what? I'm just going to get message. And also is 1 + 1 2. Just going to get both of those right there. And in fact, I'm going to do a conditional based on this. So let's see, getting some JSON. And then I'm going to say if, this other stuff, if is 1 + 1 2, then yeah, so sure, then we'll print out is it 1 + 1 = 2. Otherwise, yeah, cool. That actually was kind of a cool little Copilot autocomplete. However, I actually would kind of like to always print this message. So let's do this. Got this message, which is just going to be message. Okay. And then we're going to do this conditional. Great. So what I would like to see this do is I want to print out getting some JSON, and then it should say got this message, which should be the message that we got back from the server, which is hello from the server. And then hopefully it will agree that 1 + 1 is 2, in which case it will take this first branch and print out 1 + 1 = 2. So I'm going to leave this server running in this tab, and I'm just going to back over here, rerun rockdev demo.rock. Hey, getting some JSON, got this message, hello from the server, 1 + 1 = 2. All right, very nice. So again, this is not necessarily something that is all that impressive if you were like a dynamic language like JavaScript. All sorts of languages will do this. They'll get JSON out of a thing. They'll just turn it into dynamically at runtime, whatever types you need. It'll decode it into the appropriate format. None of this stuff is all that revolutionary if you're talking about a dynamic language. However, there is always this problem that I've always encountered in dynamic languages, which is not a problem that I have in Rock. And the problem that I always have in dynamic languages is that the error handling for all of this stuff gets really messy. Like so far, I have been operating in what I like to think of as sort of script mode. In other words, I'm writing something, this code that feels very prototypey, very kind of jamming everything out there as quickly as I can. I'm not handling any errors anywhere. I'm just kind of letting everything fail in sort of default ways. I'm not really thinking about error handling. And in dynamic language, this is where when I start to think about, okay, I want to actually make my program more robust now. I'm done prototyping. I now want to sort of transition from demo mode into sort of hardening it mode and making it more reliable. This is where the language starts fighting me, and it starts feeling unhelpful because I start to think about like, well, where could these errors be? Like what happens if one of these fields is missing? Like what happens if I try to get these things out of there, but this thing, instead of saying message, it says, message, and there's no E on it. Like what happens if that's there? Or instead of message, it says, I don't know, MSG or something like that. This code is completely separate from this code. It has no idea that that happened. Like what's going to happen? And usually what happens in dynamic languages and also in gradually typed languages like TypeScript, for example, what's going to happen is that this is just going to propagate through my program. It's going to be like, this is going to become null or undefined or something like that. It's going to print out got this message, and then it's going to print out null or undefined to the user. If 1 + 1, being 2 is not a Boolean, we might get like a runtime crash or something like that later on, especially if I got an actual number in there. All sorts of things that can go wrong that are really frustrating and difficult to deal with. So let's see what happens in Rock. Like I have not, changed anything other than I just made it so that this is returning MSG instead of message. So let me go back, restart the server, and let's just confirm real quick that that is working. Yeah, cool. So when I visit in the browser, we can see that it's coming back with this. Now, I didn't update my client code, so these are out of sync right now. Obviously, I could make a third .rock file and have them both import it, but where's the fun in that? Let's intentionally break it. So the server's still running. This thing has no idea, this client over here, the CLI, has no idea that the server was doing that, has made that change. It's still looking for this message with the old type. So let's see what happens when I actually run this. Program exited early with error, HTTP decoding failed. Huh, okay. So we got some sort of error in here that says like decoding failed. But notice what we didn't get. We didn't get this. This didn't happen. It didn't print out got this message. And it also didn't take either of these branches and printed that out. It's almost as if, and this is exactly what happened, the program exited right here. Like it was doing this HTTP.get, and as soon as it found out that this thing was wrong, it immediately exited early. Have you ever seen that before? Have you ever seen it where this isn't null, it isn't undefined, it doesn't propagate through the program, but rather it immediately fails right at the decoding site, even though we have not written a single type declaration in the entire 20 minutes that I've been demoing this. I've written 0 type annotations, no type annotations here, no type annotations here. This is all just type inference. But what's happening is that essentially Rock's compiler says, I know what these types are because of type inference. I know that message, for example, is a string because you're printing it out in string interpolation. I know that this is a Boolean because you're using it in a conditional. Conditionals have to be Booleans. So it knows that it's expecting something, a record field called message that is of type string, and it's expecting one of these that's of type Boolean. And if it doesn't get those, it's going to fail decoding right when we do this http.get right here. Because I said I expected UTF-8 JSON, and also from type inference, it knows that I expected this shape of JSON. This fails right away, even though I didn't have to spell out, here's what the schema is. Here's why I didn't have to declare anything. It just figured it all out from type inference. So this is a good example of something that's always been a goal of mine for Rock, is trying to learn from dynamic languages, but also trying to improve on it by bringing in things from the static type checking world. So if I stopped you right here and I didn't run the program and I just showed you this code, you might say, this kind of looks like Python. It's really concise. There's not basically no ceremony anywhere. I'm really printing out the absolute bare minimum worth of instructions to specify, here's what the behavior I want is. Same thing on the server. And yet what we're actually seeing is that we have already more robust error handling than I would get from a Python or a Ruby or something like that that's dynamically typed. And in fact, even in those languages, when you add static typing through gradual typing, you still don't get this. Either you get the behavior like you get in TypeScript, where this is still null or undefined and it sort of permeates through the program, or you have to explicitly write out your types and like annotate it and say, I expect message to be a string and I expect this to be a bool, and they both have to be there, and so on and so forth. Now, I'm not saying those are bad things. Those are perfectly reasonable things to want to do. And in a lot of cases, there's a really good argument to be made that it's best practice to do that anyway. But the point is that part of the design philosophy of Rock is that different workflows should be supported. It should be possible to start with a workflow where you say, I want to start out in prototyping mode, really low ceremony, and then transition gracefully into really robust, hardened, ready for release, public use mode. So now let's take a look at that. Okay, so we already saw sort of what we're getting for free in terms of type inference. Now let's start to actually get some types involved. So first of all, let me go back and actually fix this thing so that it's not going to break. Although we can like re-demonstrate breaking it later if that's useful. But one of the things I mentioned earlier is that we're not handling any errors here. And there's actually quite a few errors that could happen here. For example, what if I do this HTTP and we saw the JSON could go wrong, but another thing could go wrong is like I could just give it the wrong URL, right? So instead of JSON, I could say /JS. That URL doesn't even exist. That's going to hit our 404 path right here. Another thing that could go wrong is my network could be disconnected. I'm not going to demo that because if I disconnect my network, we're not going to be live streaming anymore. Also, there could be a timeout. There's any number of things that could go wrong here, but I'm not handling any of those right now. Similarly, actually, it might not sound like it, but even printing to standard out can go wrong. Like there's various IO errors that can happen if like the pipe gets broken, stuff like that. All of these things that have an exclamation point, these could potentially cause an error. And currently I'm not handling any of those. Well, let me change that real quick. So all I'm going to change absolutely nothing about my implementation. I'm just going to put a type annotation on main. And here's what I'm going to do. Okay. So I just added a type annotation to main and I didn't do anything else. So what does this type annotation say? So first of all, in Rock, type annotations go on their own line. I'll explain the benefit of that a little bit later. But basically what this is saying is that our main right here has the type task, and task is a type with two type parameters. First is the success type. So a lot of tasks, like for example, if I did like http.get UTF-8, it would say like, oh, I get back a string. This particular main task doesn't produce anything. So we just say empty record, which is kind of our shorthand for like nothing, no useful information here. And then the other type parameter is essentially a list of errors, like things that can go wrong. So what I've done here is I have given the command line app basically has one error that you kind of always want to have, which is sort of this generic like, hey, I want to exit with a non-zero exit code, and then I want to print out some string to standard error that says, what went wrong, like some information for the user. Now you don't have to use this. There's other ways that you can exit if you don't want to do it in exactly this way. But this is a really convenient way of doing things. And basically what I'm saying here is I'm saying, okay, this main task has handled every single error that could possibly come up, except for this one, except for the explicit sort of graceful exit. Everything else has been handled, I promise. And we notice we're seeing a red squiggle there. So let's just see what exactly the Rock compiler here is saying. For this particular example, I actually want to do something different than what I've done before. I'm going to go full screen on the terminal, and I'm going to use, instead of Rock dev, I'm just going to do Rock check. So Rock check is basically just type check it and tell me what the problems are. Don't actually try to run it. All right, so rock check says, hang on a second. There's a mismatch here. So what's actually happening is that I'm getting out this thing. This is the list of errors. So we saw it's a task with the sort of empty record, meaning, you know, I don't produce any output. Here's all the different errors that can happen in this program. HTTP decoding failed. Remember, we saw that one earlier when I made the JSON fail. Also, there's a number of things that could go wrong with HTTP itself, like the body could be wrong, request could be wrong, bad status, as like a 500 error, something like that, network error, timeout. Also, when we're printing the standard out, like I mentioned, you could have a broken pipe. It could be interrupted before it finishes printing, out of memory, unsupported, would block. Right? Like all of these things are things that the operating system can say went wrong when you're trying to write the standard out. I didn't handle any of these, but notice that the compiler knew about them. Like all that happened for me to get those compiler errors was I just put on a type annotation that claimed I'm handling all the errors except for that. If I replace this with an underscore, this is a rock type annotation feature. If you want any part of a type annotation, you can replace with an underscore, which essentially means, hey, I don't feel like annotating this part. Like I'm saying this is a task, but I'm not saying anything about either of those. In fact, if you really want to, you can go as far as to say like colon underscore. This doesn't do anything. I'm just saying like, hey, I'm annotating main with nothing. Important to note, this is not at all the same as like the any type in a lot of languages. This is underscore means like, I know, compiler, that you know what the type is. I'm just not choosing to write it down. So underscore essentially means just go back to your normal type inference for this part of the type. So when I do this, what I'm saying is I am claiming that main is a task that produces nothing, and then underscore for the error type, meaning I'm not making any claims whatsoever about what I think the error type is here, but I can still break this. Like if I say task string, it immediately gives me an error because it's like, no, this doesn't produce a string. What are you talking about? Standard out.line doesn't give you a string. What are you saying here? So if I do that, it's fine. And then also if I do this, again, it complains because it's like, no, that's not what this error type is. I'm seeing more errors than you are claiming are actually happening here. So how can I fix that? I've got these different errors here. How can I make it happy and say like, okay, I actually agree with you. This is the actual error type. So in order to do that, I have to actually handle the errors. Like there's no way around this. That's the only way that I can get it to actually handle these errors that I am claiming to handle, is I have to handle them. So this is important because this means by adding that one line of code, I have instantly switched from sort of script mode, getting up and running real fast, prototyping mode, to like, no, now all the errors need to get handled. And unlike your traditional try catch, where it's like, yeah, I don't know, wrap everything in a catch, and then hopefully you catch them all, got to catch them all. It's like, no, here's the list. Here are the things you need to handle. Like this is the errors. These are the ones that your program can produce. There are no other errors that your program can produce. These are the ones you need to handle. Okay, cool. So let's actually handle them. So the way I like to do this is I like to just sort of split this out. I'm going to make a little thing called run, and then I'm going to change main to just be run. I'm actually using the pipe operator. I'm a fan of the pipe operator. We just had an F# talk right before this, and Rock got the pipe operator from Elm, which got it from F#. So Rock is like a direct descendant of the Elm programming language, but Elm is designed for sort of browser-based UIs. It compiles to JavaScript. Rock compiles to machine code or to WebAssembly. We'll see a little bit of WebAssembly later. And essentially, so that's a little bit of where the pipe operator came from in Rock. At any rate, so I'm going to run this. I'm going to do task.map error. And I'm going to write a function called handle error. So handle error doesn't exist yet. Okay, I'll make it exist. And this is going to be give me error. And I'm going to handle it with, oops, nope, that. So this is another thing that kind of happens with Copilot sometimes. It starts writing like Elm syntax. So we say when is in Rock. Case error is the syntax that Elm uses for pattern matching. And Rock and Elm have a lot in common because Rock is a direct descendant of Elm. But that's one of the things that is different about it. Okay, cool. Also, these errors, it just totally made up and they're all hallucinations and wrong. But fortunately, we can see exactly what they are. They're right here. So let me just grab those out of the compiler error message. I'm actually not going to handle these as granularly as the compiler error tells me. So this is another nice thing about error handling in Rock is that we can be as granular as we want to be or not with this. So for example, I'm going to say, okay, if HTTP decoding failed, oh, that's a good, failed decode. I like that, thanks. And we're going to do exit status code 42, sure. And I'm just going to actually comment these out for now. And I'm going to come back later and do them. And so for right now, we're just going to have, I don't know, oops, exit 1, something bad happened. Cool. And I'm going to bring those back a little bit later. All right, so now in summary, what we've done is I've extracted my sort of happy path logic here into this thing called run, and then I'm basically saying, okay, main is just going to do that, and then it's going to handle the error using this handle error function. So if there is an error in any of these exclamation points, what's going to happen is it's going to short circuit and come down here and run this, and it's not going to continue at all. Cool. So now we should be able to see. Let me bring this back and go back and do rock dev. So failed to decode JSON. Cool. So that's what happens when we do this, and the JSON decoding fails, and then we come back down here. We see error is HTTP decoding failed, and we failed to decode some JSON. It's actually let me pause real quick. This is not planned, but I'm actually kind of curious. Why did JSON decoding fail? I thought I changed the server back. Oh, did I change it back, but I didn't restart it? That's probably what happened. Let's see. Let me just double check. Okay. Okay. Yeah, that was the problem. I didn't restart the server. All right. Okay. Well, cool. We confirmed that on the happy path still works. Now let me break it again, and then we'll get that error. All right. Okay. So now we should get the error again. Great. Failed to decode JSON. Okay. Now, again, notice that what happened here is we printed out getting some JSON, right? That happened. Then we got right here. And again, still no type annotations on this. We still only have one type annotation in our entire program, which is up here. We did http.get. The JSON decoding failed because we were looking for a field called message, but we didn't find that. Instead, we had this like other field with this other name, but that's not what we were looking for. That decoding failed on this http.get. The exclamation point, one of the things that it ends up doing is short circuiting. The short circuiting goes all the way back to here. Map error runs. Handle error says, okay, I'm going to take over from here. And now we did a pattern match on this and translated to this, failed to decode JSON. Great. Okay, now I'm going to do a different error. So here I'm going to just get the URL wrong. And this way it won't even get to the decoding step. So now when I run it, it says, oh, something bad happened. Okay, cool. So here same thing happened, except that rather than making it to this branch in the error handling, we came down here. Okay, so let's rather than just handling everything like that, I'm gonna bring these two back, and so I'm actually gonna delete the underscore for reasons that I will explain later. Okay, so we've got HTTP error. I'm gonna actually, yeah, why not? I will handle. So I think this is gonna be bad status 404. Not found. Oops. I guess I need to actually do the exit. Exit, sure. Exit 404, why not? And then for any other HTTP error, I'm going to say exit, I don't know, 1, whatever, 11, sure. Some other HTTP error. Okay, and then we had sit out error was the other one. And I'm just going to say, yeah, sit out is broken. Hopefully, sit error still works. Otherwise, you won't see this message. Okay, cool. All right, so let's run again, and now we should see not found because we hit this error 404 branch. Now, let me demonstrate something else here. So I'm going to go back to rock check mode. So here, rock check should say like, okay, cool. By the way, this is something that we always print out when we're doing rock check, among other things. We have a timer that starts when you first run the rock command line app, and then it ends like right before printing this out. And essentially, what we're always trying to be really mindful of is like how fast are our feedback loops. And this is hard coded to be milliseconds. Like we actually, like it's just MS is the string that goes in there. We don't have like a fancy like, oh, let's print out if it's like, seconds or like, because basically my view is like, if it's ever not milliseconds, that's like, we should try to fix that somehow. We should try to improve that. Obviously, there may be like some gigantic code bases in the future where like, even with caching and incremental compilation and stuff, we still can't, keep it like under a second. But that is kind of my general goal is like, as long as we can possibly have it be the case that like rock check especially is under 1 second, even for really big code bases, and the way we can achieve that is with incremental compilation and caching and stuff. We really want to maintain that if we can. Okay, cool. So this currently works fine, but now let's see something else cool. What happens if I don't handle some combination of these things? Like, for example, what if the only HTTP error I'm handling is specifically I got a 404 back? So I'm just going to comment out that branch. Boom, instant error. What's the error? This when does not cover all the possibilities. Uh-oh. Yeah, it knows. The compiler knows. And by the way, the compiler knows even if I don't annotate anything. I've deleted all type annotations from this program now. What happens if I comment this out? Same exact thing. So the type annotations really, I wasn't kidding when I said they're optional. Like it's the compiler knows it knows. And so there's no escape hatch here. There's no way to turn off the compiler. There's no null. There's no undefined. There's no any type. None of that stuff. There's no way to trick the Rock compiler into accepting something that has invalid types because it's just designed to be a sound type system. But at the same time, as you have seen, even though it's designed to be a sound type system, we've also used other design techniques for the language to try to make it so it can be really nice for prototyping. And then also it can be really nice for reliability later. And you can transition between the two really seamlessly like this. Cool. So I'm going to put back my main type annotation because, again, the whole reason I wanted to put this here is because this is the way of sort of making the compiler say, hey, you need to handle these errors because you're claiming that they are handled. The reason, by the way, that I was allowed to not put any type annotation here and not make any claim about this is that one of the features of the basic CLI platform, and I'm going to talk about platforms in a sec, is that if you choose not to handle certain errors, by default, the behavior that you get is that error message that we saw where it sort of has a default error handler that says, okay, if we run into some error that you didn't handle, like other than this exit one, which is defined to be the graceful exit one, such as a decoding error, such as an HTTP error, all it does is it really just says, I'm just going to do, print a standard error like, hey, something went wrong, and then just, sort of printing out the raw code. Something that you can do here is if you want, you can say like, other, and I can do inspect.toStir other. That's a thing that you can do. And I guess I'll just, I can demo that really quick. Yeah, so basically like what this does is it essentially just prints out like some translation of the rock code to string. This is really not something you should use for using facing stuff. This is mainly designed for like logging, for example, if you want to just like, I have some gigantic rock value and I want to just log it out. I don't want to like, have to go all the way to, like traversing the entire record and turning everything into strings manually. By the way, also, I'm not going to demo that here, but if you, a common question around this is, do I have some way of making sure that secrets don't make it into logging? The answer is yes. You can make your own opaque types and you can define with your custom types that you've created exactly what happens when this inspect.toStir runs on them, which includes, for example, saying, I'm just going to always print out some asterisks, because this is sensitive stuff that should not end up in logs. Cool. Okay, so let me put that back. Right, so you can kind of see a couple of things about this. So one is that I had to handle every single error that happens in here because I'm claiming that I've handled them all. As my program grows, I don't need to worry about like what happens if I introduce some new type of IO where I didn't handle that error like at all. Well, let's do that and see what happens. So I'm going to import CLI.standard in, and now I'm going to let's make this URL come from standard in. Oops. Actually, okay, I'm going to get that on my clipboard because that way I don't have to standard in.line. And yeah, this should now say, you can already see the error popping up right there. Yeah, thank you, Copilot. What do you think the error is? Hey, we didn't handle standard in error right here. So if I'm gonna put that down there so I can get it back in my clipboard really easily. But std error, std is broken or broke. I guess I shouldn't claim it's broken, but like whatever, it broke. All right, great. So yeah, so now we can see that again instantly. Just the fact that I started using standard in, it immediately gave me an error because it's like you didn't cover this one. So this is one of the other nice features about Rock is that errors accumulate. It's figuring these out not dynamically at runtime on the fly, but rather statically based on type inference of just seeing like, here's all the different errors that each of these different operations can do. It knows the full list of those, and then it makes you pattern match on those. This is an exhaustive pattern match in order to handle these things. One other thing, I just kind of spoiled it a little bit, but one other thing you can do is even if you don't have any type annotation, so again, I'm just going to delete this one. You can always find out the type by just hovering over it. This is like part of the Rock language server. So it's just telling me like, hey, the type of this error is HTTP decoding failed, HTTP error, etc. It just knows exactly what those types are. And even if I just change this to like crash, this is sort of your your panic button. Crash in Rock, by the way, is not like try catch. There is no catch. Crash is basically intended for like when you get to something where you're like, this really should never happen. There is no graceful way to recover from this. If we ever possibly enter this, code branch, which Ideally, you can always rule these out at compile time with careful use of types. Sometimes you can't. It's for those times. You know, I'm getting this like unused argument here, but I think it doesn't know now. Okay, all right, fair enough. Yeah, like it does need if I'm too I wonder if there's some way I can okay, let me see if I can figure it out a different way. If I can hover over the right thing to figure out how to get it to say that error without any type annotations. Okay, I mean, this works, but it's kind of it's kind of big to look at. But as you can see, okay, and actually let me try putting this back. Crash blah. Okay. I'm just going to try this out, and if it doesn't work, it doesn't work, but I think I should be able to still see, yeah, there we go, cool. So, yeah, point is that the compiler knows, like it knows the exact set of things that can go wrong in this thing just from type inference, and you can tell that it does because I'm not running the program. Nothing is running right now. Okay, the server is running, the other rock file is still running, but you know, like this is just static analysis. It's able to figure out here's the exact set of errors that are happening here. And by the way, this error accumulation feature, this is actually not specific to errors. This is actually just a general rock language feature called tag unions. I'm not going to get into too much detail on how tag unions work, but in a lot of languages, for example, you have a typical thing where you'd say like in Elm, it would be like type color equals, and then you would have like red, yeah, red, green, blue. So in rock, the way that you do that is you make a type alias of red, green, blue. These basically do the same thing. The difference is this is rock's like syntax for type alias. You basically just like make a type annotation where you're naming the type alias. Basically, what this is this is an anonymous sum type. So actually, if you want, you can go into rock REPL, which I'm going to actually demonstrate on the website because we have a REPL up here. I can just put like red in here. It's like, oh, cool, that's red. I just made up a sum type that only has red in it. And you might be wondering like, well, without doing a type alias, how am I going to get two things in there? And the answer is if I do, okay, let's see if the REPL knows 1 + 1 is 2. Red else blue. What it's going to do is it's going to say, okay, cool. So the answer is red because it took the then branch, of course. But also notice that the type of this is now either blue or red. So again, I'm not going to get into all the details on this, but this is an example of how you can use these sort of anonymous tag unions, these anonymous sum types or anonymous algebraic data types, if you want to call them that, to get sort of accumulation of values. So what's happening here is that basically, again, using type inference, it sees, well, if we take this first branch of the conditional, we might get this tag. And if we take the other branch of the conditional, we might get that tag. And so therefore, the type of this whole expression is inferred to be either blue or red. And that's exactly what's happening behind the scenes with this task stuff here. It's just that like when I run stodout.line, that function produces a task that has a particular set of errors, each one of them tagged with, you know, something like stodout error. And then when I run http.get, again, it has a certain number of errors that can happen. They're all tagged with HTTP error, HTTP decoding failed. Same thing with standard in. And so all that's happening here is really just that the compiler is just using this totally normal language feature to accumulate errors because you could accumulate tags in general, and one type of tag that you can accumulate is error descriptions. This is also another good example of one of the design philosophies behind Rock, which is to be a language that has a sort of small set of simple primitives that work really well together. We don't want to be a kitchen sink language like a C++ or a Rust that just has like a gazillion language features. Rather, we want to have a really small, simple set of language features that just work really well together and let you get a lot of like really nice characteristics together. Okay, last thing I got to talk about is platforms because we haven't talked about them yet. So this is one of the most fundamental ideas in Rock, and it's something that I don't know of any other language that does this. So far, I mean, this looks like pretty standard building the CLI stuff, mostly pretty standard building a server stuff, except that you might notice that here, main was a function that took in a request, and here, main is just a task. Like I just you know, built this thing up when I put the type annotation on main. We just said it was a task. We didn't say it was a function. Whereas here, main is actually a function that takes in a request and then returns actually a task which contains a response or an error. Now, the difference here is that every Rock application, so notice the first thing we have here is we have this keyword app. And that means that this is an application, which is to say it's an executable. when I'm doing rock dev, oh, by the way, something else I can do is I can just say rock build. So rock build basically just makes a binary executable. So I can just say, oops, ./demo, and it just runs my thing. So when I say rock build, it's building a binary standalone executable that I can just like ship up to a server or distribute to end users or whatever. Also, there's a -- target, so you can cross compile. So I can say like target and then like give it like Linux or Windows or something like that, and it'll spit out a binary for Linux or Windows. So we do have cross compilation. And basically the idea here is that we have this concept of platforms and applications because of the reality that different use cases just want different primitives. So in the example of this demo, I am writing a command line app. So I'm using this platform called basic CLI. And notice there's this platform keyword here. Like you do have to say like which platform you're building on. And a question everyone always asks is, can you have multiple platforms? The answer is no, because, well, for reasons that I won't get into here, but essentially it wouldn't make sense. You can think of a platform as something like a framework in the sense of like, that's sort of like the level of abstraction about that you're dealing with. Like when I'm importing std out and std in, I'm importing them from the basic CLI platform, which I gave a little alias of CLI for short, so I don't have to write out basic CLI or this whole long URL every time. By the way that Rock's package system works, both for platforms and for other packages, is that the reason this URL is so long is partly that we're using GitHub releases, but also at the end of every one of these, there is this hash, which is actually mandatory and checked. So this is a security feature that means that we can sort of verify the contents, and we do on download, which basically means that we don't have to worry about like the contents changing or like this URL gets taken over or like somebody's GitHub account gets compromised. That's not going to be a problem, because even if that does happen, you've got this the hash of the contents. This is a Blake 3 hash. That's going to validate it on download. So anybody who takes over this URL can't possibly change the contents of it without also changing the hash, or else it's going to fail. So basically we have this like really nice baked in security feature for that. And so there's no like node modules directory. Like if I ls this directory, we have like the demo executable that got built, the server executable that got built, and then these are just some other things in the directory for later, but and then the 2.rock files. So yeah, so every application has a platform, and the platform is responsible for things like your IO primitives. So usually like standard out and standard in most languages, those are part of the standard library. Those are not something that you get from like a framework or something like that. And the reason that we do this differently in Rock, well, there's a couple of reasons. One is security. So because these come from the platform, we haven't made this yet, but we have a design in mind for basically making an alternative to this basic CLI platform that's maybe going to be called like SafeScript or something like that. And the basic idea would be solving the problem of, I want to download a script from the internet and run it and like not worry that it's going to give me a malware or something like that on my computer. And the idea would be that this would have the same API as basic CLI, as in like the same public facing standard out, standard in, all that, such that I could just like literally just change this URL right here and nothing else about my .rock file. And now it's running in SafeScript. And essentially now the behavior would change such that whenever this script wants to do IO, like this HTTP thing, or if it were doing like a file read or a file write, it would prompt the user and say, hey, this script is trying to do an HTTP get to this URL. Do you want to allow this or not? And you could say things like, yes, I do, or no, I don't, or maybe like, yes, but only to this subdomain, or something like that. And the purpose of this would be to try and essentially mimic what the browser does in terms of safe sandboxing, so that I can download this script from the internet. I have no idea what's inside of it, but as long as I see that the platform that it's using is SafeScript, I can just run it with full confidence, because I know there's no escape hatch here. There's no way that that script can possibly be doing any IO other than stuff that's going through the SafeScript platform, because there is no IO coming out of the Rock standard library. That's just not a thing. The entire standard library has no IO primitives whatsoever. It's all done through the platform. And two, there's no escape hatches like CFFI or something like that. Again, that doesn't happen either. It's all going through the platform. So you actually can legitimately download an unknown, untrusted script from the internet from anybody and run it, and not worry that it's going to mess up your computer, because if it tries to do anything that might hurt your computer, it's going to prompt you first. So that's one of the reasons that we have this platform designed with these IO primitives. But another is just that certain IO operations just don't make sense in certain use cases. For example, standard in, blocking to read from standard in like we did here. Is that a thing that makes sense in a web server? Like, do you want your web server to be able to like block on reading from standard in? I don't. That sounds like a mistake if anyone ever does that. And yeah, maybe when I'm writing my web server, I would never accidentally do that. But the point of having this be in the platform is that now if I use some package like this JSON one or something like that I got off the internet that's sort of like platform agnostic, like this JSON one we're using in both of these two different use cases, even though they have different platforms, I want to make sure that any kind of sort of platform agnostic package that I'm using is only going to be using primitives that make sense on my platform. In other words, if I try to get a package that's relying on standard in being available and it's not, I want to get a compiler error for that. I don't want to like find out about that at runtime or like have it like block on standard in. I want to just be like, no, you can't use this thing because it's trying to do something that is not available or doesn't make sense in the context of a web server. And for an even more extreme example of this, for my final demo of the presentation, let me show you a WebAssembly rock program. So I didn't make this. I also didn't make the platform for this. So anyone can make a platform, by the way. This is not like we have a hard-coded set of them. It's just part of the language. You can make an application or you can make a platform or both if you want. So this is Rocky Bird. So Brendan Hansknecht made this, and I think Brendan and some number of other people collaborated on the platform. But basically, there's this really cool sort of retro gaming style platform called WASM 4. And the basic idea behind WASM 4 is it's a way to give you sort of the experience of like coding an old school game. If you're curious for the code for this, it's up on the internet under Rock WASM 4 and Luke Boswell's GitHub account. And you can see like, here's the text, Rocky Bird, click to start. We're not going to go through the code on this, but I'm going to show you the game real quick because it's fun and I'm probably going to die right away. Let's see what I can do. All right. Whoa, 1. Oh, 2. Okay. Oh, 3. Oh my God. This is very stressful. Oh, okay. It's worse than live coding. All right. Anyway, so that's Rocky Bird. It's a fun little game. I think my high score of all time is like 8. So, it's Flappy Bird, but in rock. But the point is, talking about platforms, like somebody made this platform for this, right? So at the top here, you're just importing the WASM 4 platform. And when you look at the imports here, it's like you're not seeing anything like standard in, you're not seeing HTTP. Not only does standard in not exist, because like, does that make any sense in the context of this thing? But also you're not going to find any like file IO primitives. File IO primitives totally make sense for CLI and for server, but like you're in the browser, you can't access the file system. That's just not a thing here. And so part of the reason for this design is to give people a way to build for lots of different domains. I like to say the long tail of use cases is what I'm targeting with Rock. In other words, not just command line apps, not just web servers, not just retro games in the browser, but also just like things like editor extensions, things like database extensions. Also, all of these little sort of niche use cases where you have an intentionally restricted environment where certain operations don't make sense. Rock is designed to make it so that in those environments, you only have the primitives that make sense. Like if I'm building a game for this WebAssembly thing, and by the way, people have made a couple of other games on this too. There's like a maze generator and like a drum machine. In that world, I don't want to have to worry about any of the dependencies I'm using potentially relying on things like file system access that I just don't make sense in this world. This concludes my sort of like demo portion of things, and I hope you enjoyed all the live coding, all that. If you want to learn more about Rock, we have rocklang.org. This REPL, by the way, obviously Rock compiles WebAssembly, but shout out to Brian Carroll. He made this work. This is actually all running in WebAssembly in the browser. This doesn't talk to a server at all. It's all just executing right here. It's WebAssembly compiler, Rock compiler compiled to WebAssembly, which is compiling WebAssembly Rock on the fly and then evaluating it all in the browser. So you can like load this page, turn off your internet connection. This will all still work just as well. We got some more examples here. And then down below here, we got this little thing where you can kind of click on things and just see like a little explanation of what everything's doing. Pretty similar to honestly, like a lot of the stuff that we just went over here. And yeah, if you'd like to learn more, this is, rocklang.org is sort of the best place to do it. I highly recommend the community tab. Rock's Loop Chat, we all hang out in there. It's like very active and people are super friendly to beginners, asking, answering questions and stuff like that. I'm just really excited about all the progress the language has made. Like a year ago, I couldn't have been able to do this demo because it's like there wasn't enough stuff to be able to demo, and a lot more compiler crashes. As it happened, we didn't run into any compiler crashes, but trust me, they're out there. If you spend enough time with the language, you'll definitely run into something because it's still a work in progress. We don't even have a numbered release yet, but you can download nightly binaries all the time, and I would love to answer anyone's questions. Thanks.
Thank you very much, Richard. Very interesting presentation. There's a lot of questions. People are shouting out like a good presentation.
Cool.
Yeah, some were already hooked
I'll
now,
let you be the
saying
moderator.
they're gonna switch to Rock or like use it at least. Check it out. There are a lot of
Well,
questions.
like
There are
I said,
actually
it's
shoot.
yeah, it's not battle tested. So, you know, if you want to like rewrite everything in Rock, I would recommend starting with something small so that you're not, you know, battle testing in production and, you know,
Yeah,
right away. But yeah.
cool. There's actually a lot of questions. I'll take some questions here, and then I think people can join Discord afterwards and ask them like the more elaborated questions. But one of the questions that came up was like, why did you choose to write the new language or go for a new language?
Yeah, I mean, honestly, it's kind of the most common reason there is, which is just that, you know, I wanted something like this to exist, and there was nothing that quite did it. So I really love the Elm programming language. It's been my favorite programming language for years now. But it's specifically targeted to like front-end web development. It's really, really focused on like browser-based UIs. And I always had all these other use cases where I wanted to use I wanted to do something else other than a browser-based UI, but I really wanted that Elm-like experience. Separately, I also had some like language design ideas that I wanted to explore that just like wouldn't make sense for Elm. But the main thing was just like I was thinking about, oh, I want to write like a Postgres extension, or I was doing a lot of Vim. You know, now I'm on the Z train because I finally found an editor that has like good enough like non-buggy Vim support. That's also like very fast and has a nice GUI and stuff. But back when I was using just Vim, I was like, I don't really want to learn Vim script. I want to, you know, do an Elm-like experience where somebody else already built a platform, if you will, that has all the primitives laid out and sort of made everything make sense for me. And I can just sit down and say, cool, I'll read some documentation. Here's how to build a plugin. I'm getting this nice Elm-like experience, type inference, you know, all the nice error handling and all that. But it's Vim script instead of, you know, in the browser. That type of thing. That's where this idea of sort of like wanting to target the long tail of domains kind of came up.
Understand. Thank you. Next question. How does the cross compilation work? What if the platform...
How does cross compilation work? Yeah. So the short answer is that Rock compiles to like just machine code. So there's no like VM. You don't have to install. I mean, okay. So if you want to like run a .rock file, obviously you have to have Rock installed. But the way it's able to compile to sort of you know, self-contained binaries is essentially that, yeah, the Rock compiler just spits out straight machine code, and it knows how to spit out machine code for like x86, ARM, WebAssembly. We have incomplete coverage, I would say, of like these from a like development backend perspective. So the compiler does know how to spit out x86 machine instructions and ARM machine instructions and WebAssembly. All of those are not, so we have LLVM, but also separately we have those backends. So LLVM, for those who aren't familiar with it, is basically a optimizing compiler backend. It's a way to generate machine code for a target, but also LLVM does all these optimizations. Unfortunately, LLVM also takes a long time to run, so it does a really good job. I actually did I didn't use optimize mode at all in anything I was just demoing. If I had built with optimizations, then it would have like taken longer to build, but then it would have run faster. But obviously, like the normal build was fast enough. So the other step, though, that has to happen is linking. So after you've done all of that, like generating the machine code, you have to link it together with something that will actually produce an executable or something like that. So this is where the platform comes in. Essentially, one of the responsibilities of a platform author is that you have to produce sort of a baseline binary executable that's sort of got all the pieces there except for the compiled Rock application. And then we have to link that compiled application together with a sort of baseline binary that comes from the platform. Right now, we do this in a lot of cases, including on macOS with the system linker, which is actually quite slow. We've got a surgical linker that is like really, really fast. So actually, if I'd done this demo on Linux, the feedback loop for especially doing Rock dev would have been even faster. So it takes like on my machine, it takes like, this is a Mac M1, it takes like 200 milliseconds to run to do like Rock dev on Hello World. That's like compiling. We saw like compiling with Rock check, that took only like, you know, 40 milliseconds or 20 milliseconds. It takes like 10 times that long to actually build and run. And that's almost all waiting on the system linker. So once we have surgical linking, that whole process should also be like well under 100 milliseconds. Anyway, the point is that all of that logic that I just described lives in the Rock compiler, whether you have the Rock compiler built for Mac OS or Linux or Windows. So no matter what system you're on, it always knows how to build for Mac. It always knows how to build for Linux. It always knows how to build for Windows. And platform authors also have to provide binaries for all those different targets. So essentially what's happening is just that, like, because we know how to build for all those things, we just have every compiler, no matter which system you're on, build for that target. So for the systems where we don't have surgical linking done yet, those we can't cross compile to completely yet. So Linux, we have the surgical linker. Windows, we have the surgical linker. Mac, we don't, which means that since I'm on a Mac, I can build for Linux and Windows. But if I were on Linux, I couldn't actually cross-compile to Mac yet because we don't have the surgical linker for that totally working. Once we do, it'll make the builds faster and finally unlock the last piece for cross-compilation for that target. Unfortunately, Mac is like the hardest one because the Mac OS like linking format is actually like really old and obscure and undocumented to the point where we know people who have talked to people at Apple and they're like, yeah, we don't know how it works either because it's like so old and undocumented that like even internally it's not known. But anyway, so that project is challenging, but once we get there, then we'll completely have it, including for Mac OS from non-Mac OS targets.
Thanks. Next question. When can people anticipate like a stable release? People are asking in the chat. Maybe they want to use it now, you know?
Yeah, I mean, so honestly, like I don't really have a timeline in my head. It's more just like when it feels right. So I want to really intentionally be very clear about like, the stability. Like right now, we're intentionally not making any stability guarantees. We have had a couple of breaking releases where we've managed to make it smooth even for people who are still using the language. So like most recently, the import syntax changed. It was kind of subtle, but if you're like watching this video later, you can go back and look at the Rocky Bird thing. The source code for that actually has different import syntax than what I was using when I was live coding. That's because we recently had the import syntax change, but actually we made it so that Rock format, like the formatter automatically upgrades you from the old syntax to the new syntax. The new syntax is going to unlock some new language features later. But like we're still thinking about backwards compatibility. We're just intentionally not making any promises about it so that people like sort of, their expectations are calibrated right. So obviously, like based on what I just demoed, you can do a lot with the language right now, and there's a lot of really nice things to love about it. But at the same time, I also want to be just really clear about the fact that it's not battle tested. There are still compiler bugs that we know about. Like the cross compilation like from macOS works, but not from other targets, etc. Yeah, like to me, the main thing is not like, let's rush to get a stable release, but rather like, let's just make sure that anyone who's trying out the language, like really knows like, clearly what they're getting themselves into in terms of this being still kind of like a bleeding edge thing.
Thanks. Final question. If people want to get involved in a rock language, is it just head over to GitHub and get involved, or get over to the
so if you want to contribute, I mean, if you want to get involved in Rock in general, I just recommend going to the website and clicking on community and then like hopping into Rock Zulip, because that's like that chat is where everybody hangs out, including if you want to get involved in contributing. Also, like if you want to donate to the project, I would love that. We're using donations exclusively to pay contributors. The more you donate, the more work gets done on Rock. So
of course.
Really appreciate any way that people want to get involved.
Okay. Thanks again, Richard. Thanks again.
Thanks for having me. This is fun.
Yeah, it was really fun. Thanks. With that, we say thanks for tonight, or morning, or daytime, dependent on where you are. And for those who are live with us, join us on Discord server, and you can ask more questions and get all the questions answered that you had and typed in the chat and on the Discord. So please, with that, have a nice evening, day, night, wherever you are. Bye, and see you in June.